welcome back to another video. In this video, I'm going to share with you algorithms. My name is Dr. Haji Tehu. Computer scientists learn by experience. This is true. If you want to learn something, you have to do it yourself. If you fail, it's also good. Why? You learn your mistakes, and then from there on, move forward. Here are the topics that I'm going to share to you. First is we're going to define an algorithm. Why do we need to study algorithms? What are the qualities of a good algorithm? Its history, application in real life, and the future of algorithm. So what's an algorithm? An algorithm is a procedure or formula for solving a problem based on conducting a sequence of specified action. A computer program can be viewed as an elaborated algorithm, and in mathematics and computer science, an algorithm usually means a small procedure that solves a recurrent problem. Another definition of an algorithm. An algorithm is any well-defined computational procedure that takes some values or set of values as input and produce some values or set of values as an output. Why do we need to study algorithm? Number one, time is gold and money is energy. So, in computer science, computers are designed to help people manage its tasks efficiently. So for computers, in order for them to perform its instruction or its program, computer programmers or scientists need to create a well-defined algorithm in order for them to maximize the use of computers. Take note, computer does not know what to do. The programmers need to provide them with instructions known as algorithm and perform its tasks. So what makes a good algorithm? First, input and output should be defined precisely. Each step in algorithm should be clear and ambiguous. Algorithm should be more effective among many different ways to solve a problem. Here, there are different strategies that you can employ in solving a problem. So a computer scientist must be able to identify the best possible algorithm to make the program more efficient and useful for people to use. An algorithm should not have computer codes. Instead, an algorithm should be written in such a way that it can be used in similar programming languages. So in this video, I'm going to share to you the history of algorithm. Please watch.
We think of an algorithm as something new, but the term actually dates back about 900 years. The word algorithm comes from the name of a Persian mathematical genius, Muhammad ibn Musa al-Khwarizmi. He was born around 780 AD in the region now known as Uzbekistan. His name suggests he came from Khwarizma. Known as al-Khwarizmi, he was director in the House of Wisdom, an intellectual center for scholars in 9th century Baghdad. He made innovative contributions to mathematics, astronomy, geography, and cartography, and wrote an influential book called Concerning the Hindu Art of Reckoning. 300 years later, the book was rediscovered and translated into Latin. It introduced Hindu-Arabic numerals to the West, which eventually replaced the unwieldy Roman ones. The Hindu-Arabic number system, along with the decimal point, both described by al-Khwarizmi in his book, are the basis of the numbers we use throughout the world today. Al-Khwarizmi's name, when Latinized in the title of the book, became algorithmi, and this is the origin of the word algorithm. We also have al-Khwarizmi to thank for the word algebra, which comes from another of his works. His books revolutionized mathematics in the West, showing how complex problems could be broken down into simpler parts and solved. In medieval Latin, algorithmus simply meant the decimal number system. By the 13th century, it had become an English word and was used, for example, by Chaucer. But it wasn't until the late 19th century that algorithm came to mean a set of step-by-step rules for solving a problem. In the early part of the 20th century, Alan Turing, the British mathematician and computer scientist, worked out how, in theory, a machine could follow algorithmic instructions and solve complex mathematics. This was the birth of the computer age. During World War II, he built a machine called the bomb, which used algorithms to crack the Enigma code. Today, algorithm is a fairly common term, even if sometimes we are not exactly sure what an algorithm does. Algorithms are everywhere now, helping us to get from A to B, driving internet searches, making recommendations of things for us to buy, watch or share, and predicting how we vote or who we fall in love with. This little word that originated in medieval Persia is gradually transforming our lives.
Applications of an algorithm. Number 1. Your life is an algorithm. Your brain is an operating system. Day to day, we try to figure out what to do. So, if you have seen earlier, algorithms are steps, so you could apply it in your daily life. Like, let's say, taking a bath, going to the mall, and so on. Okay? Algorithms are used in games. So here we have a simple game that allows us to identify where we put the X and O's, or tic-tac-toe. Now, normally, what we do here is that we would allow the users to, let's say, put these values and then determine who would be the winner. Now, you could also apply this to some of the popular games such as Flappy Bird. So here's the output. This is how the programmer or the developer identifies the logic or how the bird will flow from the game. It can also be used for genetic algorithms, in programming, and also in searching. It could also be applied into algorithms. So, what is the future of an algorithm? Algorithms can be used for artificial intelligence, big data, machine learning, robotics, and deep learning. So I leave you with this quote coming from Linus Torvalds, coming from the developer of Linux. Bad programmers worry about the code. Good programmers worry about the data structures and then their relationships. So this is our introductions to algorithms. Thank you for watching my video. Bye.